possible if you are inside the core. So if you own an own PE router, or you get somehow access to the core, then it will show us another tool which is called MPLS redirect.
Yeah. Okay. As mentioned before, it assumes that you're inside the core. You need core access for this demo. So you're too fast. The MPLS redirect is a simple command line tool. It is written in C because it has to be fast, and it's all about modification of VPN labels. So it redirects traffic from one customer VPN into another customer VPN. Think about you just bought your new high-speed MPLS VPN from location Amsterdam to location Brussels, and you think, okay, I'm secure, it's a VPN, it's my virtual private network, and nobody will ever see the data I'm transmitting over this VPN. Now, there is a second customer which uses the same MPLS backbone network and got its own VPN. If you got core access, you can actually manage it to redirect data from the one VPN into another VPN. So we will show you that. First, this is our lab setup. We got two different VPNs. The one is red, the other is green. We call them beer and spliff, as this talk was originally held on Black Hat in Amsterdam. So this was a really
sensible definition of the VPNs.
Yeah, right. And we got some PE routers. We got some PE routers which are part of the MPLS cloud. Okay, so we will demonstrate you now that there is some ping from location red to location red is working. So this is like the setup should work.
Yes. To show you what I'm located on, I'm located with my laptop with a serial console on this PE, because if you're using also the CEs here on the lab, there are a lot of more devices to set up. So I'm located or connected to this PE via serial, and my notebook is this CE. So this here is my IP address.
So this is actually the PE router.
No.
So and we will ping now from the red VPN into the other location of the red VPN. So this is working as expected. That's the normal behavior. You can ping your own other site. Maybe the upper one is Amsterdam and the downer one is Brussels. So you can communicate from one side to the other.
Yes, the statement red in the ping command was if there's created a ping statement on this router, make sure only if it comes from the red VPN, it will be forwarded in the red VPN. So we are simulating this CE.
Okay, the next step is trying to ping from a red VPN into the green VPN.
So we have to switch my notebook to another.
No, not that.
Ah, okay. Yes, I'm too fast.
You're too fast.
Okay.
Okay. So we're just trying to ping from the red VPN into the green VPN, and as you could imagine, this won't work. So all the pings are timed out.
Yes.
Okay. So again, it's a normal behavior. Now there is some magic come into play, which are the MPLS redirect tools. So I will switch over to my notebook and launch up two instances of the MPLS redirect. I got just a few arguments, which are the interface, the incoming and the outgoing interface, and the incoming and the outgoing VPN label. which is incoming label 19. Okay, if there is a packet labeled with label 19, I will relabel it with the label 20 and put it back onto the wire. So that's the first tool instances for one way of the communication, and I will launch up a second instance of this tool just for the second data flow of the communication. So we need two unidirectional communication streams, so I need to launch up two tool instances. Okay, after the tools are running, I will switch back to Roga.
Here we are.
The first thing you see is there is no warning. The PEs don't even mention my tool instances. It's absolutely transparent. Okay, now we will ping again in the red VPN, which is working like before. And after that we will ping in the green VPN. And as you see, this ping is working too. So what happened here?
Yes, to make clear what it's about, this redirection. You have these VPN labels, these MPLS labels, and these labels are based on the information which in VPN, which MPLS VPN, the red one and the green one, is separated. So it's all about the labels. There is no other encryption in these VPNs or something else, just the labels.
Okay, so after there was some magic, we are in a state where we can reach the other customer side. So think about it's like, I don't know, the IBM network is now connected to the Intel network. So just by relabeling traffic.
Yes. So what does it mean? What does it mean if someone inside the cloud can relabel this information, and you can use this information to set up some maybe fake central authentication portal? You can use this information to grab all the corporate passwords and use them for your own purposes. You can set up a DNS and look for all the DNS information transferred to or inside of the network, or you can use it
for sure you can answer DNS requests.
Yeah. So you can use your own imagination what you can do if you can relabeling all the packets and can send or receive information.
So we were on this state and said, okay, this is quite cool, because if you got an own VPN inside the MPLS cloud, you could just insert some data into another VPN. But in this scenario, you also need a VPN. But wouldn't it be nice if you could just insert some traffic inside a VPN without owning another VPN? Yeah, it's possible. I wrote another tool which it's called MPLS TUN. The TUN is for tunnel, and what it does, it also assumes you're inside the core. Just remember, all the time we are talking about breaking MPLS, you need access to the core. So what this tool does is it just creates a new virtual interface, tunnel interface, and this tunnel interface gives you, or is part of a MPLS VPN. It gives you an MPLS VPN enabled network stack. It's only tested on Linux so far, but I think there should be no big problems by porting this to BSD or some other platforms. Okay, so we got another demo for this. So I will switch back to my notebook and launch up the MPLS TUN command. So it got quite a lot of arguments. So the first one is we are now in layer 3.